Hi students, welcome to today's class. In the previous class, we were discussing about equations of motion. Are you remembering which are the three equations of motion? Yes, V is equal to U plus AT, that is the first equation. S is equal to UT plus half AT squared, that is the second equation. V squared minus U squared is equal to 2AS. Out of this, we had derived the first equation of motion. Yes? Now, today we are going to do the derivation of remaining equations of motion. Can we start? Yes. For deriving the equations of motion, what is the first thing I have told you to do? That is, draw the velocity time graph of the uniformly accelerated body. So, here we are having the velocity time graph of the uniformly accelerated body. So, AD gives the velocity time graph. Yes. Now, from the graph we had seen how to calculate distance travelled or displacement of the body. Yes. How? Are you remembering? Last class I had told you. Find the area under the graph. So, what is the area under the graph? Here I have represented that by, see here you can see some shaded part. Yes or no? That is area, distance travelled or displacement of the body. Remember, it is uniformly accelerated body. As a result, the direction is not changing. So, when we say distance travelled or displacement of the body, both are becoming the same magnitude, no change. So, from the graph, distance travelled, I represent it by S is equal to area under the graph. What is the shape of OADC? OADC is the area under this part graph. So, S is equal to area of OADC. Now, look at the shape. What is the shape? It is a trapezium. Yes or no? Yes. But what I am going to do here, to find out the area of trapezium OADC, I have divided the trapezium into two parts. First, a right angled triangle ADB, that is shaded by red. And second, the rectangle OABC. So, the total area of this trapezium is sum of the areas of triangle plus rectangle. Got it? So, S is equal to area of triangle. What is the name of our triangle? Triangle ADB. ADB plus area of rectangle OABC. Rectangle OABC. OABC. Now, we are going to find out one by one area. Which is the first one? Area of triangle ADB. Are you remembering how to calculate area of a triangle? Some mathematics, come on. Which is the formula for area of a triangle? Half into base into altitude. Yes. So, half. What is the base? AB. Previously we had seen that what is base? AB is equal to T. So, half into T into what is our height? Height is equal to dB. Yes. Now, how much is the height dB? Are you remembering? It is DC minus BC. What is DC? V. What is BC? U. So, what is dB? dB equal to V minus U. So, half T into V minus U. Now, what is our first equation? First equation, A is equal to V minus U upon T. A is equal to V minus U upon T. I want V minus U from this equation. What should I do? Just cross multiply. What am I getting? AT equal to V minus U. So, from this equation, I will get V minus U is equal to AT. Understood? From the first equation, I am getting V minus U is equal to AT. Now, I am going to substitute V minus U by AT in this equation. Clear? So, I am getting here S. Area of the triangle, only triangle part is there. Remaining part, we will add it. Half T into, what is V minus U? AT. Plus, now what is the left out part second? Area of the rectangle. What is the formula for area of the rectangle? Base into height, LB. Are you remembering mathematics? Yes, all are remembering. Good. So, length is how much? OC. Breadth is how much? BC. From the graph, what is OC? T. What is BC? U. BC is the same as OA. So, U. So, here what we will get? Plus UT. So, this equation S is equal to half T into AT. What are you getting? So, here S is equal to half, as it is I have written, T into AT, what we will get, right? AT square, T into T square plus UT. So, happen, this is our second equation. What is the second equation? S is equal to half AT squared plus UT. Are you remembering how to do it? First velocity time graph, fast I will say. First velocity time graph, then area under the graph gives us the distance travelled by the body. Yes. So, how we have calculated the area? The full figure, we are getting a trapezium OADC. Trapezium I have divided here into two parts. One is one triangle and a rectangle. Then I have calculated the area of the triangle and the area of the rectangle separately. Then I had added it. Area of the triangle, that is triangle ADB, plus area of the rectangle, rectangle OABC. Clear? Now, next part, I have taken, what is the area of triangle? Half into base into altitude. So, half into, instead of base, T, altitude it is dB, that is V minus U. Then what I have done? V minus U I have replaced from the first equation. Clear? So, I got that part, half into T into, instead of V minus U, AT. Now, what is the next part? That is a rectangle. What is the area of the rectangle? Length into breadth. Length is OC, that is T. Breadth is OA, that is U. So, U into T, UT. Total, what is the area? S is equal to half AT squared plus UT. So, this is our second equation. See, this is for you to write in your fair book. Full steps are written clearly. You can see distance travelled equal to area of figure. What was the figure? That is trapezium. Okay. Then area of rectangle plus area of triangle. Same thing what I have taught you. For your fair book to write it neatly, again it is given. Clear how to do second equation? All of you understood? So, shall we move to the third equation? Yes. What is our third equation? Third equation to do same thing, velocity time graph of uniformly accelerated motion. In this also we are going to calculate distance travelled. Here distance travelled S is equal to, what is we are getting? The full area, that is this, the full I am going to take it together. Understood? This is trapezium OADC. Same thing, but coming to third equation, the way we are calculating the area of the trapezium is different way. Here coming to third equation, area of trapezium we are going to calculate by using the direct formula of trapezium. Come on, let me test your mathematics. Who will give me the direct formula to find out the area of a trapezium? Who is the one remembering? Yes, come on, tell. Half into height into sum of the parallel sides of the trapezium. What is the formula? Half into height into sum of the parallel sides of the trapezium. So, which is our trapezium? Trapezium OADC. For this trapezium OADC, which are the parallel sides? Parallel, I hope that you know it this way. Yes. So, OA parallel to DC. Clear? So, parallel sides are OA and DC. Now, trapezium you keep it in your mind the other way so that you will get the height. So, what will become the height? Height is equal to OC. Clear? So, I will write S is equal to area of trapezium OADC. Clear? What was the formula we used? That is equal to half into H into sum of the parallel sides, that is OA plus DC. Clear? Half into height into OA plus DC, sum of the parallel sides. Our work is over. Now, what is the step next left? All these what we have written, that we will represent it by the OA is equal to U and DC is equal to V. Then what we will write? It is equal to half into H. What is H represents? T into OA plus DC U plus V. Now, only one work. When T is here, that T we have to replace again from where? First equation. So, what was first equation? A is equal to V minus U upon T. If I want T from that equation, what should I do? T I have to take in place of A. So, what will be mine? T is equal to V minus U by A. Okay, understood? T I have taken from our first equation, A is equal to V minus U by T. T will come A's place, A will go to T's place. Understood? So, T is equal to V minus U by A. I am going to replace that here. So, this is equal to half into, what is T? V minus U upon A multiplied by U plus V. I am going to write U plus V plus U. Okay. Now, here S. What should I do next? This 2A is denominator. I will multiply that by s by a cross multiplication. So, what I am getting? 2as equal to, now come here, v minus u into v plus u, v minus u into v plus u. Again, are you remembering something mathematics? 8th standard you have studied. Yes, this is your identity. Which identity? Third identity. What was that? A plus b into a minus b is equal to a squared minus b squared. Same. We are taking something from mathematics in physics. Yes, otherwise we cannot do it. So, come on here. V minus u into v plus u. A minus b into a plus b. So, what we will get here? V square minus u square. So, our third equation happened. 2as equal to v squared minus u square. This is our third equation. Now, for u, derivation is done. See here, full derivation you can write down in your fair book. Okay, I hope that you understood it. Now, last a small topic is left in the theory part, which is that uniform circular motion. Uniform circular motion. When I say circular motion, you understood it. The motion is only along a circular path. Clear? But something more we want to understand in this. What is that? That is, for a circular motion, 2 points to remember. That one, speed remains constant. Second, the velocity of the body changes. That means direction is changing continuously. Understood? So, remember what is uniform circular motion? Motion of a body along a circular path. 2 points to remember. For a circular motion, always the speed of the body remains constant. Second, direction will change. Now, everyone is getting a doubt how the direction will change. I will tell you. See, this is a circular path, one body is moving. It reached up to here. Suppose from there it's moving away from the path. Example I will tell you. Early morning you take a cup of tea, put sugar inside the tea, take your spoon. What you will do? You will do a rotational motion or you will give a circular motion to it. If you are doing that circular motion very fast with your spoon, some droplets of that tea will fly away. Which direction it will go? That is along the tangent. Along the tangent. So, this point, see the tangent is this direction. Suppose it is moving away from here, the direction is this. Now understood why I said for a uniform circular motion the velocity changes, because the direction is continuously changing at any point. That is, at that point, what is the direction of its tangent, which gives the direction of the body. Otherwise, its speed remains constant. So, how we will find out its velocity? Velocity is equal to displacement upon time, or here speed is equal to 2 pi r upon t. Why did I take 2 pi r? Total distance travelled upon time taken. So, remember S is equal to 2 pi r by t. So, I hope the full theory part you understood. Revise it properly. We will use the thing while we are solving our numericals. Thank you.